All right, this video is brought to you by ARE Study Warrior, studiously preparing architects for the difficult set of 6 ARE NCARB architectural registration exams for licensure. Today's video focuses on building joints in architecture. Please don't forget to hit that subscribe and like button below if you enjoy our content and want to hear more. Today's lesson will cover isolation joints, expansion joints, control joints, construction joints, as well as several others. All right, so without further ado, let's get into it. Understanding building joints in architecture. There's several important types of building joints to know for your exams, specifically the PPD and PDD exams, and for your career as an architect. It's important to know the difference between them. Building joints can be between 2 or 3 units of the exact same material, or they can be a connection between 2 or 3 very different materials. On a broad level, there are 2 categories of joints in buildings. There's movement joints and there's non-movement joints. Movement joints are meant to allow movement, of course, and non-movement joints are not meant to allow movement. Pretty straightforward. Examples of movement joints would be isolation joints, construction joints, expansion joints, pretty much all the ones we'll cover today. And then non-movement joints we won't really cover today because they're not as complex. For instance, they would be mortar joints between masonry blocks or a screw connection in the wood frame of a house. So those are non-movement joints. And here's a quick diagram breakdown showing the different building joints. Going right into movement and non-movement joints. As you can see, all the complex joints are under movement joints. All the ones we'll cover today are movement-specific joints, and we won't really talk about non-movement joints. And this diagram isn't always helpful. It can be actually more confusing in some ways, so let's dive deeper into each of these. So the 4 main concrete joints would be control joints, expansion joints, construction joints, and isolation joints. You should know by quickly looking at a joint section what type of joint it is. But these 4 types of joints are also used in other materials, not just concrete, just so you know. So let's start with control joints. When you think control joints in buildings, you normally think of concrete material, or you should think of concrete material. They're purposely created lines of weakness made to minimize random cracking and help control where the surface is going to crack. You're purposely creating these points of weakness in the concrete. They're shallow joints, cut roughly 1/4 inch depth of the slab thickness. The best example of a control joint would be sidewalks. They have regular visible control joints, as do larger concrete floor slabs and concrete walls as well. And unlike expansion joints, control joints are not compressible. That is not their purpose, so remember that. Control joints are often tooled while the concrete is still wet, but they can also be cut after the concrete's cured. And there's a quick detail of a control joint. Commit that to memory. Very simple detail. As you can see, control joints are one of the simpler joints. Construction joints. These are also relatively simple joints. They're used when separating 2 successive concrete pours. For example, a new pour is made against a section of concrete that was poured last week. Normally, reinforcing in the form of rebar is used connecting and extending between these pours. That's often why you'll go on site. If you go on site, often or not, you should see rebar sticking out of concrete a foot or 2 if it's in the middle of construction. And that's just because it's awaiting the next pour that will cover that rebar. Construction joints are also keyed, which is important to remember. And this helps connect the 2 pours, as you'll see in the detail here below. There's that key joint in the middle between the 2 pours right and left of the key joint. And then that rebar positioned horizontally is connecting those 2 slabs. That's a simple detail of a construction joint. They're also used to separate one type of material from another. For example, a wood door frame caulked connection within a brick facade. These joints allow for clearance between materials as well as allowing for differential movement. And they create an area of weakness and a location where water leakage can occur. Therefore, you need to protect against that with water stops that are placed during the first pour. Abutment joints, which you may hear, are basically construction joints. because they often separate new construction from adjacent old construction. And I believe that first diagram is a little misleading in that because it makes it more complicated than it is. As far as the ARE goes, you can basically say that abutment joints are construction joints for the most part. They connect a new brick building to, for instance, a 25-year-old brick wall. Just remember, construction joints are a point of weakness, and they're unavoidable in construction. All right, expansion joints. These are the more difficult ones, the more complex ones. Their purpose is to allow for thermal or moisture expansion and contraction within the building. They're often capable of moving in two different directions, two different planes, if you will. The typical width of expansion joints is a 1/2 inch to 3 inches, so that's a wide range. They can vary. There are material expansion joints, and there are whole building expansion joints, and they are often detailed in a similar way. However, a through building expansion joint is much larger and would be used to completely separate two sections of a building. And there's a quick detail of an expansion joint showing the basics: the expansion joint filler in the middle, the expansion joint cover covering the surface, and then that movement, which would usually be on two different planes, that expansion contraction movement. Expansion joints should be located at geometric discontinuities in buildings such as corners and changes in the height or width of a surface. Where walls change direction, you should try to locate vertical expansion joints adjacent to corners, and sometimes even one vertical expansion joint on either side. For an unbroken wall length, it should not exceed 125 feet for masonry walls or 200 feet for concrete walls. So that's the maximum that they can be. If they do exceed either of those, then you need an expansion joint or several of them. So an example, expansion joints in brick walls allow the bricks to slightly expand under wet conditions, and expansion joints within aluminum curtain walls permit the aluminum elements to increase in size when warmed by sunlight. Remember, aluminum has a very high coefficient of thermal expansion, the highest of the metals. All right, and lastly, out of the main joints we covered in the beginning is the isolation joint, which allows for two adjacent sections to move independently while still sealing the joint to protect from the elements, i.e. water and air. It's not as complex as an expansion joint, but it's more complex than a control joint. They often have a joint filler that allows for expansion and contraction. It's used to separate concrete slabs from the concrete foundation wall or separate concrete columns from slabs. And here's a quick detail of an isolation joint showing that expansion joint filler in the middle between the two slabs, if you will, or between a column and a slab. All right, now getting to the other joints that are not used as often, but definitely important still. Slip joints. These allow for independent motion of larger components while enabling them to be joined in some way. They can look very different depending on the application. For instance, you use a slip joint in the header of an aluminum storefront system to allow for deflection from above. That's a common use of a slip joint. Good to commit to memory. And then pipe supports are often slip joints to allow for thermal expansion or contraction of the pipe relative to the support. Building separation joints. So these consist of settlement joints and seismic joints, which are a bit more rare and are used at the whole building level. Settlement joints, definition would be designed to avoid stress anticipated by different rates of foundation settlement between different portions of a building. They're used when differential settlement is anticipated on the project. So what is differential settlement? When the soil foundation is deemed unpredictable, an unequal settling of the building foundation occurs at one edge versus another edge, that's differential settlement. Seismic separation joints. The definition for that would be they divide a geometrically complex building into smaller units that can move independently of each other during an earthquake. So, of course, seismic joints are used often when the building is in a seismic zone. All right, question and answer. A key joint would likely be what type of joint? It would be a construction joint. When a wall slip joint is present, it is there to allow for expected what? For deflection. A standard brick mortar joint is how wide? This wasn't covered in the lesson, but it's important to know. That would be 3/8 inch standard. This type of joint is normally formed by tooling when the concrete is still wet. That would be a control joint. Unlike expansion joints, control joints are not what? They are not compressible. This is the type of joint typically used to separate concrete columns from slabs. That would be an isolation joint. And bonus question, also not covered earlier. A gasket seals a surface by blank tightly against it. A sealant seals a surface by blank tightly to the surface. So fill in those two blanks, and they would be what? Gaskets compress against the surface, and sealants adhere to its surface. That's standard, always the case. Important to remember those two things. So thanks for using ARE Study Warrior, and we'll see you in the next practice video.